Dear students, in this class we are going to discuss what is nuclear charge, how nuclear charge affects atomic radius or ionic radius. Okay, let us start. Let's consider an atom. This is a nucleus. Nucleus consists of protons and neutrons. You know protons have positive charge. That means nucleus have positive charge. The positive charge of nucleus is also called nuclear charge or nuclear force. And electrons revolve around the nucleus. Electrons have negative charge. So, since these two are opposite charges, there will be a force of attraction between nucleus and electrons. This force of attraction is also called nuclear force of attraction. This is also called centripetal force. Okay, if we observe generally, as the nuclear force of attraction increases, the nucleus pulls the electrons towards itself. That means electrons are pulled by the nucleus strongly. When electrons are pulled by the nucleus, then size of the atom get reduced. So here, as the nuclear force increases, atomic size or atomic radius get reduced. So both are inversely proportional. Conversely, as the negative charge increases, means charge of electrons increases, nuclear force of attraction decreases, then electrons move bit away from the nucleus, then its size will increase. So let us discuss in detail. And in last class we have discussed about cations, how the cations are formed, and anions, how the anions are formed. So let's take a few more examples here. Sodium, whose atomic number is 11. It has 1s2, 2s2, 2p6, 3s1 configuration, 2 electrons in first shell, 8 electrons in second shell, and only 1 electron in the last shell or outermost shell. To get the octet configuration, to get 8 electrons in its valence shell, it has to lose this outermost electron. When sodium loses that outermost electron, it becomes Na+. That means uni positive ion or cation. Now its electronic configuration is 1s2, 2s2, 2p6. Now what's the difference between sodium neutral atom and sodium ion or cation? Here in sodium neutral atom there are 11 electrons. Obviously 11 protons will be present since its atomic number is 11. But in Na plus cation there will be only 10 electrons, but the protons will be same, 11 protons will be there. Then whose number is greater? Number of protons are greater. By how many units? 1 unit. So since number of protons are greater by 1 unit, that plus 1 we have mentioned here. Here plus 1 means number of units of protons are greater by 1 unit. So when the protons, charge of protons increases or number of protons increases, nuclear force of attraction increases, then electrons get attracted towards the nucleus. Then obviously size of the atom or size of the ion get reduced. So among sodium neutral atom and sodium ion, whose size will be greater? The size of sodium neutral atom will be greater than sodium cation because it has more protons. When the protons becomes more than electrons, nuclear charge increases. When nuclear charge increases, electrons get attracted by the nucleus. Ultimately size of the ion get reduced. Okay, understood? Now let's come to one more example. Magnesium. Magnesium, whose atomic number is 12, its electronic configuration is 1s2, 2s2, 2p6 and 3s2. First shell 2 electrons, in second shell 8 electrons, in last shell there are 2 electrons. To get octet configuration, that is neon configuration, it has to lose these 2 electrons. Then after losing 2 electrons, it gets plus 2 charge. Why it is getting plus 2 charge? We'll see. 1s2, 2s2, 2p6. Now these 2 electrons are lost, so 3s0. Now it has got octet configuration. What's the atomic number of magnesium? It is 12, means it has 12 protons and 12 electrons. After losing 2 electrons, minus 2 electrons, after losing 2 electrons, it will have 12 protons. There will be no change in the number of protons, but in the case of number of electrons, there will be reduction. That is, electrons are reduced by 2 units. Since number of protons are greater by 2 units, it has got plus 2 charge. Okay. Now, when the positive charge or number of protons increases, the remaining electrons, 10 electrons, are strongly attracted by the nucleus. Its size becomes less. So, among magnesium atom and magnesium ion, whose size is greater? Magnesium neutral atom size is greater than magnesium ion. So here dipositive ion is formed. Similarly, we can discuss for many cations. Finally, what we can conclude from these 2 examples, the size of neutral atom is always greater than the, its corresponding cation. Right? Now let's move on to anions. How anions are formed? Anions are formed by the gaining of electrons. Let's take an example. Fluorine, whose atomic number is 9, its electronic configuration is 1s2, 2s2, 2p5. It has 2 electrons in first shell and 7 electrons in the last shell or outermost shell. To get octet configuration, it has to gain 1 more electron. Here only 7 electrons are there. It needs 1 more electron to get octet configuration. So after gaining 1 electron from other atoms, it becomes F minus. Now its electronic configuration changes to 1s2, 2s2, 2p6. Its electronic configuration, now it has 2 electrons in first shell and 8 electrons in outermost shell. So it becomes stable. Since its atomic number is 9, it has 9 protons and 9 electrons. But due to gaining of 1 electron, F minus anion will have 10 electrons, but number of protons will be same. There will be no change in the number of protons. Either it is a neutral atom or cation or anion. Only there will be a change in case of number of electrons. Since number of electrons are greater by 1 unit, so it has got minus 1. How many protons are there here? 9. Number of electrons are 10. So electrons are greater by 1 unit. So it has got minus 1 charge. When the number of electrons becomes more and nuclear force of attraction becomes less. When nuclear force of attraction becomes less, then electrons feel free to move. When the electrons move bit away from the nucleus, obviously the size of the ion or size of the atom will increase. So among F and F minus, that is neutral atom and its anion, whose size will be greater? Yes, obviously the size of anion will be greater than its neutral atom. Let's take one more example. Oxygen. Oxygen's atomic number is 8. Its electronic configuration is 1s2, 2s2, 2p4. It has 2 electrons in first shell, 2 plus 4, 6 electrons in the last shell. To get octet configuration, it needs 2 more electrons. So after gaining 2 electrons, oxygen becomes O minus 2. Since its atomic number is 8, it has 8 protons and 8 electrons. After gaining 2 electrons, there will be no change in the number of protons, but number of electrons becomes 10. That means the number of electrons are greater by 2 units. So we have mentioned -2. When the number of electrons becomes more, nuclear force of attraction reduces and size of the atom becomes more. Okay, so size of oxygen neutral atom is less than its di-negative ion. So from these two examples, what we can conclude, the size of neutral atom is always less than the size of its anion. So once again we'll recall these concepts. Here size of neutral atom is greater than its cation, but size of neutral atom is less than its anion. Here concept is very simple. So suppose here I have some chalk pieces, 4 pieces. If I make these chalk pieces, big pieces, into still some smaller pieces, and I will fill my pocket with all these pieces. Suppose some 20 chalk pieces are there in my pocket. Okay, now if I am keep on removing the chalk pieces one by one, then what happens to the size of my pocket? Yes, obviously size of my pocket will gradually reduce. Similarly, when we are keep on removing electrons from the neutral atoms, cations will be formed and their size will be gradually decreases. Next, conversely, now my pocket is empty. Now I am keep on adding one chalk pieces one by one. Then what happens? My pocket, after some time, the size of my pocket becomes large. In the same manner, when we are keep on adding electrons to neutral atom, the size of the neutral atom gradually increases. So finally, what we can conclude? Size of the neutral atom is always greater than its cation, but it is always less than its anion. So among cation, neutral atom and anion, whose size will be greater? Anion size will be greater than neutral atom. Neutral atom size is greater than cation. Okay, here one small question to you. I will give a series of isoelectronic species. You try to predict which is the largest ion and which is the smallest ion. C-4, N-3, O-2, F-, Na+, Mg+2, Al+3, Si+4. Here, what are the atomic numbers of these species? Carbon 6, nitrogen 7, oxygen 8, fluorine 9, sodium 11, magnesium 12, aluminum 13, silicon 14. Now, sodium, after losing one electron, its number of electrons becomes 10 electrons. Magnesium atomic number 12, after losing 2 electrons, its number of electrons becomes 10. Aluminum atomic number 13, after losing 3 electrons, its number of electrons will be 10. Similarly, silicon +4 also 10. It has 10 electrons. Now come to fluorine, atomic number 9, after gaining 1 electron, its total number of electrons becomes 10. Oxygen 8, after gaining 2 electrons, it becomes number of electrons becomes 10. Similarly, nitrogen 7 + 3, 10. Carbon 6 + 4, 10. Don't be confused. Here minus is there, 6 - 4, 2. Okay. Here -4 means it has gained 4 electrons. So already 6 electrons are there. 4 more electrons are gained. So 6 + 4, 10. Here positive charge is there. Positive means loss of electron. 11 electrons are there. 1 electron is lost. So 10 11 minus 1, it becomes 10. Okay, don't be confused. You should not do like this: 11 plus 1, 12, 12 plus 2, 14. That's the wrong way. Okay, try to understand the concept. Now the question is, among these isoelectronic spaces, why these are called isoelectronic spaces? Because all are having same number of electrons. These are called isoelectronic spaces. Among these isoelectronic spaces, which is the largest one, which is the smallest one? Can you predict? Just before this topic, I will tell you, just before this topic, I told you that cation has smallest size, then neutral atom, next anion. So as the positive charge increases, size get decreased. As the negative charge and the anion increases, its size gradually increases. So here nuclear charge is plus 1, here plus 2, here plus 3, here plus 4. As the positive charge increases, nuclear charge also increases. As the nuclear charge increases, the size of the atom get reduced because electrons are get attracted towards the nucleus. Okay, there will be more attraction. More positive charge means more attraction towards the nucleus, and electrons move slightly towards the nucleus and its size becomes less. Next, in case of anions, as the number of electrons increases slowly and steadily, as the number of electrons increases, okay, nuclear force decreases. As the nuclear force decreases, electrons move slowly, gradually away from the nucleus. So size of the anion gradually increases. So among these, which is having more nuclear charge, more positive charge? Silicon, Si plus 4. So it is the smallest ion, and C minus 4, it is having more negative charge. So it is the largest ion. Shall I ask one more question? Among Na plus and Mg plus 2, which is larger? Na plus is larger because Mg plus 2 is having 2 units of positive charge. As the magnitude of positive charge increases, size of the cation decreases. Next, among O minus 2 and N minus 3, which is larger? N minus 3 is larger because as a negative charge increases, the size, negative charge means number of electrons, the size of the anion gradually increases. So N minus 3 is greater in size than O minus 2. Okay, I hope you understand this concept. This is a very basic and important concept. Okay, the same concept again in detail we will discuss in our regular classes. Okay, thank you.